Hey everyone, in this video we are going to solve the code schedule 2 question on Leetcode. So before that we have solved code schedule 1. It is pretty similar. The question says we are given an array of prerequisite and in order to complete course A, we must complete course B first. The only difference between the previous question and this one is we also have to return the order in which we can complete all of these courses. So to solve this particular question, we'll be using BFS and TopoSort. I'll explain what TopoSort is in a minute. And if in case there are multiple ways to go through all of these courses, we can return any of them. That will be fine. And if we were not able to complete all of these courses, then we'll just need to return an empty array. So this is the question. Let's see how we can do it. So this is the input. And if we create a graph of this particular one, so we have in total 4 nodes. So we have node 0, node 1, node 2 and node 3. For 1 we have a dependency on 0. So 0 will be connected to 1, then 0 will be connected to 2, then 1 will be connected to 3 and then 2 will be connected to 3. So this will be our graph and we'll be using BFS to solve this particular question along with topological sort. So topological sort basically means that if there is an edge from connecting node U to node V, so U should always appear before node V. So topological sort can have multiple outputs. So in the question we have also mentioned that if we have multiple ways to complete all of them, we can return any one of them. That will be fine. So topological sort only work on a directed acyclic graph. So this is a directed graph and it must be an acyclic graph. Acyclic means that there should be no cycle present. So what will happen is if we run topological sort on this particular graph and we were not able to go through all of these nodes, that means there is a cycle present, because topological sort will only work if there is no cycle present. If topological sort, we were not able to perform topological sort on this graph, that means there was a cycle present. So what we'll do, we'll run a BFS and run a topological sort. And if we get all of these nodes, that means we were able to complete all of these courses. Otherwise, there's a cycle present and will return false. So how we can perform topological sort? So basically, we have to calculate in degree for each of these nodes first. So by in degree, we mean how many edges are coming to that particular node. So for 0, we have 0 nodes coming to node 0. For 1, we have 1, 0 to 1. For 2, we have 1, 0 to 2. And for 3, we have 2 in degree, from 2 to 3 and from 1 to 3. Now, the one which have 0 in degrees will add it to a queue. Right now it's node 0, we'll add it to the queue. We'll run the BFS and we'll reduce the degree of each of the neighbor nodes by 1. If any of the neighbors in degree become 0, then we'll add it to the queue. So let's see how we'll do. We'll start from node 0, we'll pop it from the queue. So we'll check what are the neighbor nodes. The nodes are 1 and 2. So we'll reduce their in degree by 1. So we'll reduce in degree of 1 from 1 to 0 and of 2 from 1 to 0. Now, how many nodes are there with in degree 0? There are 2 more, 1 and 2. So we'll add these two, 1 and 2. Now we'll pop 1 from the queue and we'll check what are the neighbor nodes of 1. It is 3. So we'll reduce the in degree of 3 by 1. Cool. So are there any new nodes with the in degree 0? No, not right now. So we'll keep moving forward and we'll pop 2 from our queue. So for 2, what are its neighbor nodes? It's 3. So we'll reduce its in degree by 1. So in degree of 3 will become 0. And now we'll add it to the queue. Then we'll pop 3 from the queue. There are no neighbor connected nodes to 3. There are no nodes to where we can go from node 3. So we'll stop our BFS and this will be our output 0, 1, 2, 3. Now as we got all of these nodes, all of the 4 nodes, that means there was no cycle present and we can complete all of these courses. But if we were not able to get all of these 4 nodes, if any 1 or 2 or any single one of them was missing, that means there was a cycle present and we couldn't complete all of these courses. So the time complexity of this particular question is O of V plus E. V is the number of nodes and O is the number of edges. And the space complexity is O of V since we are storing all of the nodes in a queue. So that was the drawing explanation. Let's see how we can do it in code. So let's first define our topo sort array. So topo sort equal to an empty array and also define our queue. Let's define our graph as well. We'll be using map data structure to create a graph and an array to calculate to store all the in degrees. So array of num courses. So the size of the array will be number of courses and each index will contain 0 initially. Now first create our adjacency list. So for const e comma v of prerequisites. So if that particular node is already present in our graph, so if graph dot has v, we need to push e in the already existing array. So graph dot get v dot push e. But if it is not present, that means we'll create a new array. So graph dot set for key v and value will be new array with node e in it. We'll also update the in degree as well. So in degree for node e plus plus will increase the in degree of node e by 1. Next we'll check if there is any in degree. So I is less than 0. So if there is any in degree with 0, so if any course has in degree 0, we'll push it to our queue. So I is less than in degree dot length and I plus plus. We'll check if in degree at I is equal to 0, then simply push it to our queue. Queue dot push I. Now we have created our graph and we have inserted our first node in our queue. Now let's run the BFS. So while queue dot length will get the node, so queue dot shift, it will return as the first element from our array. Shift method, it will return as the first element from our array. Then we'll check if graph has that particular node or not. So graph dot has node v. If this node v is present in our graph, then we'll get all the neighbors of this particular node. So const e of graph dot get v will get all the neighbors, all the connected nodes of node v. Will reduce their in degree by 1. So we'll reduce their in degree of node e by 1 minus minus, and then again we'll check if the in degree of node E is equal to 0. So after reducing the degree by 1, if the degree becomes 0, we'll push it to the queue. We'll push the node E to the queue. And we'll also add at the end this node V to our toposort array. So toposort.push V. And at the end, we'll check if we get all the nodes or not. So we'll return if number of courses is equal to toposort dot length. So if we get all the courses, this condition will be true. Then in that case, we'll just return our toposort array. Else we'll return an empty array as the question said. So if we run this, it's working. Let's submit it. Yep, it's working as well. So that was it for this video. Thank you for watching.